Find the present value of an ordinary annuity which has deposits of $10,279 semi-annually for 5 years at 7.6% compounded semi-annually. This is the formula for present value. Since the problem asks for the present value, this is obviously the formula we need. The next step, of course, is to identify what each of the letters stands for and find the value. Now, these are all the letters used in this formula. Capital P is the present value of the ordinary annuity. Capital R is the periodic payments, the amount you make payment on periodically throughout the term of the annuity. Little t is the time in years, little r is the annual interest rate, little m is the number of compounding periods per year. You have to calculate little I as little r over little m, and little n is little m times little t. So really we've got to the point now where we just need to figure out what these letters are. The problem asks for the present value, so that's obviously what we're searching for, so that's what we'll be finding. The periodic payment is $10,279. That's the deposits we're making semi-annually. So that's the periodic payment. $10,279. The time is given as 5 years, so T is 5. The annual interest rate is 7.6%, but we want to write that as a decimal. We move the decimal 2 places to the left, so that would be 0.76 as a decimal. And the number of compounding periods per year, it says semi-annually. That's twice a year, so m is 2. Now little I is little r divided by little m, so little r is 0.076 and m is 2. And if you divide that, if you can't do it in your head, you can certainly go to the calculator and do it. You get 0.076 divided by 2 would be 0.038, and m is 2 and t is 5, so n is 10. Now once you've gotten those values, you simply plug them into the formula and use your calculator to solve for capital P. So let's just do that. Let's see if we can solve this. We're looking for capital P. Capital R is $10,279. And you've got this fraction. The numerator is 1 minus the quantity 1 plus little I, which we've calculated to be 0.038. And that's raised to the negative n power. N is 10, so that'd be negative 10. And then the denominator is little I, 0.038. Now it's strictly a calculator problem from here on out, so let's make some room to do these calculations. Maybe I can slide this down here, although we really don't need it anymore. So we've got P is equal to $10,279 times. Okay, you can do this any correct way you want. You don't have to mimic me exactly, but this is the way I do it, and we are using this Casio FX260 Solar School Edition. I would start here, 1 plus 0.038. You can do it on your calculator, or you can just realize that that's going to be 1.038. Then you want to raise that to a power, so you hit the power, you click the power key, x to the y. Then you want to put in a negative 10, but in this calculator you cannot enter a negative number directly, so you enter the positive counterpart, just 10. There's a button labeled plus minus. If you press that, it changes the sign to the opposite. So if it was positive, it turns negative. Now there's a negative 10 in as the exponent. So you simply have to click equal to evaluate it. So I click equal and I get the quantity raised to the power. So I've gotten this in the calculator. But it should be negative, not positive. Well, that's a perfect time to use the plus minus key again. So I take this number that I've calculated as positive and change it to a negative by hitting the plus minus key. And you see a negative sign pops in front. Now the only thing I'm missing out of the numerator is this positive 1, so I just simply add 1, plus 1, and then press equal. That's the entire numerator. I want to divide it by 0.038 and hit equal. That's the entire fraction. Now you can keep this number in the calculator, not ever write it down as an intermediate step, but just in case you want to come back later and practice this and use this as a guide, I'm going to write down right here what you get, so it'll be there. But in reality, you don't even have to put that intermediate step on the paper. And so we're done when we do that multiplication. So the present value is the product of this number and this number. That number is already in the display, so I hit times 10279 equals. So the present value of this ordinary annuity is $84,208.20.